All right, so section 1.3 in our Algebra 2 book deals with solving linear equations. Now, a linear equation is just an equation with one variable. Okay, so all the ones that we're going to see today are just going to have, well, in this lesson, 1.3, are just going to have one variable. It's not going to be an exponent variable, so it's not going to be a quadratic equation. It's not going to have a square. So, example A here, and I label my examples with lowercase letters. It's just the way I've always done it. 2x plus 5 equals 21. Let's think back to junior high when we first started solving equations. And I realize that you guys have been out of Algebra 1 for nearly 2 years. I realize it's been a while, right? But the objective to solving an equation, which is two expressions set equal to each other with an equal sign, is to get your variable by itself. Sometimes you hear us say isolate your variable. So if you isolate something, that means you get it by itself. All right? And the way we get our variables by itself is by using something called inverse operations. Now, an inverse operation is basically the opposite of an operation. It's something that mathematically undoes something else. So what do you think undoes addition? Subtraction. What undoes subtraction? What undoes multiplication? What undoes division? Yes. Something that we might forget about sometime. What about if we square something? What's the inverse operation for squaring something? I don't know. Taking a square root. Very good. So we're going to solve this equation for the x. Here's our variable. By moving everything away from the x using our inverse operations. So the first thing I want to move is that 5. That says plus 5, right? So mathematically, what do I do to get rid of plus 5? Subtract 5 on both sides. And these cancel out because if I add plus 5 minus 5, that makes 0. So on the left side of the equal sign, I have 2x equals, and what is 21 minus 5? 16. And then I have a little one-step equation left. What does this mean? 2x. What does that mean? No, not the 16. What does 2x mean? 2 times x, right. Anytime you see a number and a variable squished together, they're being multiplied. So, if that means 2 times x, how do I get rid of the 2? Yeah, divide both sides by 2, and I get x equals what? 8. And you can check your work. 2 times 8 is 16 plus 5 equals 21, right? And I checked that in my brain. I didn't have to write anything down. I didn't have to put anything in the calculator. But I just checked it in my brain, and it worked. Okay? And notice, what's that red stuff on the screen? That's my work. That's me showing my work. So I do expect you guys to show your work in here. That's how I can figure out what you're doing, and if you make a mistake, where you might have went wrong so I can help you, okay? If you don't show me work, I don't understand if you missed something where you might have went wrong. Example B, here's another one. Negative 10 plus 4x equals negative 34. So I have an x, and I want to get everything away from the x. So the x is on the left-hand side of the equal sign. So I want to move everything that's on the same side as that x to the other side of the equal sign. So what do y'all think we're going to do first? Very good. I'm going to add 10 to both sides. I'm going to erase my line. If you like your lines there for your equations, that's perfectly okay with me. So I've got 4x equals what? What's negative 34 plus 10? Very. I divide both sides by 4, and x equals what? Yeah, negative divided by positive is a negative 6. So watch out for those pesky little negatives. But very good job. Appreciate it. Good job. Does anybody have any questions on anything we've covered so far? This is review, right? Right? We've done this before. Good news for us. All right. Then life gets a little bit complicated for you guys, not for me. When the heavens open up and fractions fall down. Okay? Now, something you are never going to see me do in solving an equation that has a fraction in it is see me change that to a decimal. Miss Isabel doesn't play like that, and I don't want you guys to play like that either. Y'all are grown or nearly grown, and we're not changing fractions to decimals in my class. We're going to solve it like a fraction should be solved. Okay? So, we don't even need the fraction for the first part. What do I need to do to get everything away from the x? What's the first thing I need to do here? Subtract the 8 from both sides. All right? So then I have left 4/5 x equals what? What's 20 minus 8? 12. Very good. Okay, so that's 4/5 times x, right? So what I really need to do is divide by that 4/5, right? Now let's think back of fraction arithmetic there. Y'all remember something called keep, change, flip? Right? So when you're dividing fractions, you keep the first one, change the operation to multiplication, and then you do the reciprocal of the second fraction, right? Well, to save us a step, anytime you have a fraction times your variable, I want you to multiply both sides by the reciprocal. So that just keeps you from having to So when you do that, this left-hand side of the equal sign, that equals 1. Because 5 times 4 is 20, 4 times 5 is 20, and 20 divided by 20 equals 1. So that's how that cancels out, because it equals 1. So x equals, I'm going to put that 12 over 1. And I can multiply across, and I'll be 60 over 4. And then I can simplify that. Or I can simplify as I go. And the way we simplify as we go is we find any common factors. So is there a number that will go into 12 and 4? 2 does, but is there a bigger number that does? 4 goes into both of them. All right. So what's 12 divided by 4? 3. What's 4 divided by 4? 1. So that makes our fraction simplify a little bit quicker, and it keeps us from having to multiply by such big numbers. And I multiply across. 3 times 5 is what? 15 over 1. 1 times 1 is 1. Or you can go ahead and tell me x equals 15. So you can skip that next to the last step right there, that 15 over 1, if you know the denominator will be 1. Any questions about that? Let's see one more like that. Example D, 2/3 x minus 7 equals 5. So we're going to go through this one. And if you have a question on it, stop me. But it's going to be very similar to the one we just did. All right, so I want to get the x by itself. So somebody tell me what I'm going to do first. Good. We're going to add 7. So 2/3 x equals what? What's 5 plus 7? 12. I didn't mean to use the same number on both of them, but it's okay. Now, how's the quickest way to get rid of that 2/3? Multiply by the reciprocal of 2/3. And what is the reciprocal of 2/3? What does reciprocal mean? Well, it's not the opposite. It's the inversion, basically. The numerator becomes the denominator, and the denominator becomes the numerator. Opposite means you change the signs. So 3 over 2 is correct. Y'all know this stuff. Y'all just haven't seen algebra in about a year and a half. And y'all put 12 over 1, and we can reduce that as we go. Do any of my diagonal numbers reduce? The 2 and 12 are both divisible by what? 2. What's 12 divided by 2? 2 divided by 2? And somebody besides my buddy Addison tell me what is 6 times 3? And it'll be over 1, so the answer is x equals 18. Any questions? 7th graders can do this, right? Okay. I want you guys to try a few practice problems. Get out my book. They're on page 19, but I'll write down the problems for you. All right, so I want you, with your pencil and your paper, to work these problems out right now. We'll check them in a minute. Solve them both for x, please. Everyone participate. If you get stuck on something, let me know. All right, when you finish, check it with a neighbor who's also finished. If you're not finished, keep on working. All right. Everybody, all at once, tell me what you did on number 1 first. What'd y'all do first? Okay, that's one person. I hear 9 voices. What do I do first? Thank you. That was 2 voices. I still need 9 voices. What do we do first? Thanks. But they even got Dylan Holt talking to me. Looky there. So 4x equals what? What is 21 minus 9? 12. And then what do we do to solve for x? Raise your hand high. What do we get? What do we get? X equals what? 3. Raise your hand high if you got x equals 3. Y'all are seriously rock stars. Everybody gets 100 on that problem. You still got it. There you go. All right, number 2. Negative 3/5 x plus 1 equals 4. What did we do first to get x by itself over here? Subtract 1. So that gets me negative 3/5 x equals what? What's 4 minus 1? 3. My kindergartner knows that. All right. So, how do we get rid of that negative 3/5? Use its reciprocal. What is its reciprocal? Very good. And make sure you keep it negative. And put that 3 over 1. And can I reduce something over there? Yeah, the 3's are both divisible by 3, obviously. So those equal 1. So x equals what? Negative 5 over 1, which is what? Negative 5. Raise your hand if you got x equals negative 5. And if you got positive 5, stick a negative on there and pretend it didn't happen, right? All right. Hey, we're practicing. We got to knock out some rusty stuff up in there. I haven't done algebra for a while. I completely get it. Do what? WD-40 on it. Yeah, that fixes everything. I used it on my recliner just the other day. All right, let's go to some where we have variables on different sides of the equal sign. Example E, 7p plus 13 equals 9p minus 5. 7p plus 13 equals 9p minus 5. All right, when we have the variables on opposite sides of the equal sign, the first thing we want to do, if we don't have any distributive property or like terms or anything like that, is get those variables together using our inverse operations. Which one's bigger? The 9, and they're both positive. So it's going to make more sense, or it's going to be easier for me, if I go ahead and subtract this 7p on both sides. Because it's a little bit easier sometimes to deal with positive numbers rather than negative numbers. So it's easier for me sometimes to go, if they're both positive, subtract the smaller one from the bigger one. So that leaves me with 13 on the left equals, what is 9p minus 7p? 2p, good. And then subtract 5. All right, now it's an equation just like we've already seen today. So what do you think we're going to do next to get the p by itself? Good. And then 13 plus 5 is what? So 18 equals 2p. Divide by 2. And p equals what? 9. And I don't care if you write p equals 9 or 9 equals p. It's reflexive. It goes both ways. For inequalities, you can't just swap them, though. So as long as these are equations, I don't care which way you get your answer. Let's do another one similar. 8y minus 16 equals 13y plus 9. Somebody tell me what you want to do first to get your variables together. Subtract 8y. Me too. So those will cancel. And it leaves me with negative 16 equals, what is 13y minus 8y? What's 13 minus 5? Well, I just said what it was. 13 minus 8 is what? So 5y plus 9. And now what do we want to do, you reckon, to get the y by itself? So we subtract 9 and get negative 16 minus 9 is what? Negative 25 equals 5y. And then we can divide both sides by 5. And what is negative 25 divided by positive 5? It's what? Negative 5 equals y. Very good. So that's what you do when you have a variable on both sides of the equal sign. So now let's make it a little bit more complicated. 3 parentheses x plus 2 equals 5 parentheses x plus 4. So now we haven't done any with parentheses yet. What does it mean, do you think, from your memory? Does anybody know what it means when we see these kind of parentheses? It means multiply. We're going to distribute. We're going to do something called a distributive property on both sides of the equation because they both have parentheses. That means, for example, with 3, we're going to multiply it times the x and also multiply it times the 2. So anytime we have a number against parentheses with variables inside, we're going to distribute, which means multiply it times every term on the inside. So what's 3 times x? 3x, very good. And what is 3 times 2? 6. Equals, same thing on the other side. What's 5 times x? 5x. And what is 5 times 4? 20. And now it looks just like a problem that we've been doing with variables on both sides. So how do we get our x's together? A couple ways. Somebody tell me one way I can get my x's together. You can subtract 5x. You can also subtract 3x, right? It really doesn't matter. Me doing it this way instead of the other way, I just have a negative 2x. But that is A-okay. We will get the same answer no matter which way we do it. So somebody tell me what I'm going to do next to get x by itself. Subtract 2. So negative 2x equals 14. I divide by negative 2 and I get what? Negative 7. Any questions on that? All right, let's make it a little bit more difficult. Slightly. Problem H, we're going to say 4 parentheses 2x minus 9. Not an equal sign there. Plus 5 equals negative 3 parentheses 10 minus x. Sorry, I'm kind of scrunched up over there on the end. So it's a little bit complicated. What do you think is the first thing we're going to do, though? Yeah, first thing I'm going to do is going to distribute and get rid of those parentheses, right? So 4 times 2x is what? 8x. Let's write that down. And 4 times negative 9 equals what? Negative 36. Very good. And I'm going to copy that plus 5. It had nothing to do with the distributing part. And then on the right-hand side of the equals, I have negative 3 times 10 equals what? Negative 30. And be careful here. What is negative 3 times negative x? Positive 3x. Y'all are rock stars. I'm impressed. Yeah, negative times a negative is a positive, so make sure you put a plus 3x right there. All right, if you notice, over here on the left side, these two terms don't have variables. So they are what we call like terms. So we can combine those. So what is negative 36 plus 5? So let's go ahead and combine those and get 8x minus 31 equals negative 30 plus 3x. So now after I've done all my distributing and combining like terms, I can start going across the equal signs to get my x's together. Okay? So somebody tell me one way I can get my x's together. Very good. And what is 8x minus 3x? 5x minus 31 equals negative 30. Now what can I do to get x by itself? Add 31. So I have 5x equals what? What's negative 30 plus 31? 1. And now divide both sides by what number? Not 1. Yeah, the one with the variable. I know it looks weird. And x equals, do not tell me that is 0.2, leave it 1/5. It's perfectly okay to get fraction answers. Okay? Just make sure they're simplified, and 1/5 is a simplified fraction. So y'all don't freak out if you get a fraction answer. It's going to happen a lot in this class, okay? Just make sure it's simplified. It's okay if it's improper. Okay? Any questions about that one? Are we good? Took a little while on that one, didn't it? It did. Let's do one more like that, just for practice sake, since I've showed you everything. And then we'll do a you try. So that was example H. Let's do example I then. This one says 3 parentheses 5x minus 8 equals -2 times -x plus 7 and then minus 12x. It looks longer than the first one we did, but it's actually exactly the same as the one we just did, stepwise. I just stretched it out longer because I had more space. So, y'all get it copied down. So, what do y'all think we're going to do first here? To solve for x. What do we need to do first? How do we tackle this? Come on, run out of space. We're going to distribute, right? Get rid of those parentheses. I don't want to see them anymore, so we're going to distribute that. So 3 times 5x is what? 15x. And what is 3 times -8? -24. Be careful with your signs. Good job. Now over here, we really need to be careful with our signs because we have a -2 outside the parentheses. So make sure you multiply by -2 and not just +2. So what is -2 times -x? +2x. Very good. And what is -2 times 7? -14. And then this one don't have anything to do with the distributing, so I just need to copy it. Y'all see something that we need to address on that problem so far? Yeah, there's 3 x's. And the reason there's 3 x's is because these two over here on the same side of the equal sign, meaning they're like terms. Right? So if they're on the same side of the equal signs as each other, then they're like terms and you need to combine them before you start going to both sides of the equation. So what is 2x minus 12x? Very good. -10x. So copy the rest of it. 15x minus 24 equals -10x minus 14. And I combined the two that I underlined there. And now we can start going to both sides and get our x's together. So how do y'all want to do that? Yeah, I would add 2 because I'd rather add than subtract personally. And what is 15x plus 10x? 25x minus 24 equals -14. Then what can I do to get x by itself? Add 24 to both sides. That gets me 25x equals -14 plus 24. 10. So now what do I do to solve for x? Divide by 20. Yep. 2/5. Because you can divide those by 5, right? Always simplify your fractions. Please do not tell me decimals. Any questions? All right, I want you guys to try this one. -4 times 2x plus 5 equals 2 times -x minus 9. Sorry, that parentheses looks funky. I'll fix it. Still does, but you got it. And that's a 5, not an S. My handwriting's terrible. 5 look like S. So I apologize. Let me know if you have a question. All right, let's distribute those. What is negative 4 times 2x? Negative 8x. What is negative 4 times 5? Negative 20. So make sure you put minus 20 there. What is 2 times negative x? Negative 2x. And what is 2 times negative 9? So be very careful when you're using distributive property that you use the correct signs. Okay? Then somebody tell me what you're going to do. Yeah, you can get your x's together. Now, okay, this is where your work might look differently than mine. It might look different than somebody else's, okay? You could add the 8x to both sides, or you could add the 2x to both sides. Both are correct. Both will get you to the correct answer if you do everything else correctly, okay? So don't start erasing if you don't do what I'm doing right here. Okay? So, because you can add either one. We still should get the same answer. I don't do that. Hey, and I'm good with that. If you have another way you can do it and you get the same answer and you show me your work on your paper, I'm good. Okay? I'm not one of those picky teachers that are like, you have to do it my way. Okay? The world don't work like that. Right? Well, some bosses are like that, but I'm not. So if you can logically and mathematically correctly show me what you did on your paper, I'm A-okay. Right? That's just how I am. Because I know I'm not a genius. And I am not Jesus, and my way is not perfect, and other people have other ways of doing things that make sense to them, and I'm perfectly okay with that. Cool? So I'm doing it this way, and I'm getting negative 6x minus 20 equals negative 18, and then I'm adding 20 to both sides, and I'm getting negative 6x equals 2, and I'm dividing by negative 6, and I'm getting x equals what? Negative 1/3. Raise your hand if you got something that's simplified to negative 1/3. Any questions? Okay, a lot of people did it, and we probably all did it a different way, didn't we? Right? And that's perfectly okay. Do what, Dalton? Okay. All right. So we're going to move on and do a second section today. That will be normal for us to do more than one section, because we've got to cover this whole book in less than 18 weeks. And this is something that is not always easy for people, because sometimes it's difficult for people to understand how to solve an equation when all you have is variables. And that's what we're going to be doing in this section, is we're going to be rewriting equations to highlight one of the variables mentioned. So that's what we're doing, is rewriting equations and formulas today to specify one of the variables. All right, so these are they look like word problems just because I have to write them out in sentence form, but you don't have to write every little thing I write down for the problems on here, okay? You need to write the formula. So C equals 2 pi r. We're going to solve that equation or that formula for r. And then we're going to find the radius, which is what r is referring to, of a circle with the circumference of 44 inches. Now, you don't have to write all that down. You can just write C equals 44 inches. Find R. So, what we're going to do first, it's like a two-step process. There's two things we have to do. The first thing we have to do is solve C equals 2 pi R for R. Now, that's the formula for the circumference of a circle. It's a geometry concept. Okay? Twice the radius times pi is the circumference of a circle. We're going to solve that equation, that formula, for R. So we're going to take this and solve it for R. We're going to get the R completely by itself. Okay? Pi is not a variable. Pi is a number. Right? What does pi approximate to? 3.14. It's not equal to 4, but it's rounded to 3.14. We use that a lot. Okay. So, we're going to solve that equation for R. Ignore this stuff over here until you get the equation set equal to R. Okay? Because it's overwhelming if you try to think about it all together. Okay? So ignore what you're trying to do, substituting with 44 inches till after you get it equal to R. So, how is the 2, the pi, and the R all connected to each other mathematically? They're squished together, right? Which means what's happening to them? They're multiplied times each other, right? So if I want to get rid of everything except for the R, what can I do to it? What's the opposite of multiplying? Dividing. So if I want to get rid of the pi and the 2, all I have to do is divide both sides by 2 pi. Right? And those cancel. And so I have C divided by 2 pi equals R. I did the first thing it asked me to do. And put a box around it because I answered one of the questions. All right. Then it says to find the radius of a circle who has a circumference of 44 inches. So that means I'm solving for R, but they told me that one of the pieces of this puzzle is 44 inches. Now, which variable do you think I'm going to replace with 44 inches? C. C, right? So I'm going to have 44 divided by 2 times pi. We can say pi is approximately 3.14. If you have one, it might be handy to get it out for a few minutes. If not, you can just wait till the end of the lesson and borrow one. So, I need to multiply these two on the denominator, right? Right? And now do 44 divided by that answer. So 2 times 3.14 is 6.28. And so 44 divided by that, I'm getting the R is approximately 7.01 inches. Now, why did I say approximately? Because I rounded, right? What did I round? I rounded pi, right? Because pi doesn't equal 3.14. That's its approximation. So that's why I said it's approximately. And my calculator said 7.006. So that's why I rounded again when I wrote that. Also, units are important. They told me my circumference was in inches, so I assume that my radius is also going to be in inches, okay? So make sure you don't leave out units when they require them. Any questions about this one? It's not that bad, was it? No. Just solve it for the variable and then plug it in. Let's try another one. Solve A equals LW for W. Now, what is that the formula for? What's that the formula for? Area of a what? Or a rectangle, right? Area of a rectangle is area equals length times width. So first they want us to solve it for W. So let's do that first before I even tell you what the rest of it says so we won't get confused. So how do I get that W by itself? Divide by the length. So A divided by length equals W. One step and I was there. Is everybody okay with that? So next, I'm going to find the width when the length equals 16 meters and the area equals 40 square meters. So how am I going to find the width when the length is 16 meters and the area is 40 square meters? How do I do that? Yeah, I'm going to substitute my A for 40 and my 16 for L, and then I'm going to divide them. Very good. So 40 divided by 16 is going to equal my width. And we can go ahead, since we're rounding this, it makes sense if you're talking about meters to give a decimal. So since it makes sense to the problem, so it's going to be about 2.5. What's my units here? Meters equals the width. 2.5. Okay. Let's do one more. P equals 2L plus 2W. What's that the formula for? That's supposed to be a plus, not a T, sorry. What's that the formula for? Perimeter of a rectangle. Okay? So solve it for the width. So we want to get that W right there by itself. So first, let's subtract that 2L. Now, these are not like terms. That P and that L are not like terms. So all you can do is write P minus 2L. So is everybody okay with what I did there? I know this gets confusing when you got lots of different variables going on, but it's still just inverse operations. So if I have 2 times the width left over and I want the W to be completely by itself, how am I going to get that W by itself? Divide by 2. Very good. So, solving it for W, I get P minus 2L divided by 2 equals W. Okay, good job. Next, it's going to ask me, find W. This is part 2. Find W when the length is 12 meters and the perimeter is 41 meters. So how do I do that? Plug in for my variables, right? So what goes in for P? $41. So I'm going to say, I'm plugging it into right here, okay? So 41 minus 2 times what goes in for L? 12, and I'm going to divide by 2. Okay? So what's 2 times 12? 24, right? And then 41 minus 24. What is 41 minus 24?
8.
And then 17 divided by 2. And 2 goes into 17 8.5 times. So 8.5. What's my units on that? Meters? Good job. Okay. These might be a little confusing. What's next? Or they might not. You might think these are easier. That was example C. Here's example D. 9x minus 4y equals 7. Solve for y. And then find y when x equals negative 5. So we're doing the same thing. Except for it's not really a formula for anything specific. It's just a linear equation with an x and a y. Okay? So you could solve it by just rearranging, or you could put it in slope-intercept form, because when you solve something with just x and y, it's basically put in slope-intercept form. We're going to talk about that in a few days, but it's not really necessary that you do that today. So I'm just going to solve it for y. I'm going to move everything away from the y. So that 9x has got to go. So how do I get rid of that 9x? Subtract it. It's positive 9x, so I can subtract it away. Very good. So then I get negative 4y equals 7 minus 9x. And then what's with my y now? I'm going to divide everything by negative 4. Now, for today's purposes, since we are just starting out in our Algebra 2 world, if you leave it like that, I'm good. Later on, we will find another way to write that. All right, so then I have to find y when x equals negative 5. So how do we do that? Negative 5 in for x. So y equals 7 minus 9 times negative 5 divided by negative 4. So I just plug from there, I just put in my negative 5. So then I'm going to multiply that. So what is negative 9 times negative 5? Positive 45. And what is 7 plus 45? 52, isn't it? And I divide by negative 4. Does anybody know what 52 divided by negative 4 is? If you know cards, you know what this is. And it's negative 13. Yeah, that's how I remember that, is there's four suits in a deck of cards, and they have 13 cards each. That's how I remember 52 and 13. Yeah. If I didn't know cards, I wouldn't know that as easy. So there you go. Let's do one more like this. And then we'll pretty much call it a day after that, I believe. I believe. Mm-hmm. 5x plus 3y equals 8. Solve it for y. And then find y when x equals 2. All right, first let's solve it for y. What do y'all think we're going to do first to get y by itself? Subtract 5x. Very good. And those are not like terms because 8 don't have an x, another one does. So 3y equals 8 minus 5x. And then what do we do? Divide everything by 3. We can just leave it like this. Y equals 8 minus 5x over 3. We'll put a box around it. Then I'm going to do the second part. Find y when x equals 2. So how do we do that? 2 for x. Very good. So y equals 8 minus 5 times 2 divided by 3. And what's negative 5 times 2? Negative 10. Oh, sorry, I need to put 8 minus 10. Divided by 3. And what is 8 minus 10? And negative 2 divided by 3 is just negative 2/3, right? It won't simplify. Let me see if I need to do one more. I think I'm good. All right, so that is the end of the lesson for today.